Hello, today we're going to continue our investigation of polynomials with the product of powers. So this deals with how do you multiply polynomials or monomials when you have different kinds of exponents. So let's look at this box up here, and in the box it gives us an idea of how this is done. And I'm going to show it to you in a couple of different ways so that you can get a good idea. So in this first example, a squared times a cubed equals a, so this is a squared, times a, which is a cubed, and that's a equals 5. Another way that I would like you to look at this is the same as a, and so when you're multiplying these a's and they have different or exponents, what you do is you add the exponents. So it would be 2 plus 3, or again a to the 5th. What we could do with all these a's is if we just line them up, a, that's your first two, a, that's your next three, and then we count it, that's 1, 2, 3, 4, 5. So we know that we have 5 a's multiplied together. That's what the exponent is. Alright, so the rule is when you're multiplying variables with exponents, you add the exponents together. So let's look at number 1. We can do this. We can do 1, 2, 3, 4, 5, 6, 7 times 1, 2. And so if we put them all together, there are 9 a's. We could also do this. Or, excuse me, that should be x's. I'm sorry, I was still stuck with a's in my head. So if I have x to the 7 plus 2, that's equal to x to the 9th. So please think of all these as x's up here, not a's. I did not write it properly. All right, so on number 2, what do we do when we have a 3? Well, there's only one 3, so I'm going to put that right there. And then I'm going to go ahead and write k times 1, 2, 3, 4, 5, 6, 7, 8, 9. So then that would just be 3k to the 11th, which is the same as 3 times k to the 2nd plus the 9th. Okay. On number 3, it's exactly the same. We don't have any other number for the 4 to be multiplied by, so it's just 4. And then I can write x to the 9th. Now the parentheses is the same thing. This is the same thing as this for multiply. Okay? So 9 plus 3. And that gives me 4x to the 12th. Alright, number 4. Well, they're going to actually give us some numbers to multiply. So what I want you to do is I want you to, since you have these numbers together, we're going to multiply 3 times 4. So 3 times 4. Let's put that in parentheses. And then w squared times w to the 12th. And so that's 12. And then times w 2 plus 12. And that comes out to 12w to the 14th. Now 12 is not raised to the 14th power, only w is. So let's look at 5. X 7 plus 5, which equals x to the 12th. And we could write that out. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. And if you count them all up, there are 12 x's. We could do the same here. 1, 2, 3, 4, 5, 6, 7, 8 times g to the third, g, g. Oh, g. That would be 11 g's. G times 8 plus 3 equals g to the 11th. So remember, when you're multiplying variables that are raised to an exponent, you add the exponents together. On number 7, where you have numbers to be multiplied, you multiply your numbers, and then you multiply your exponents, or you multiply the variable with the exponents, you add the exponents. So 2 times 4 is 8, x, and 2 plus 3 is 5. I know it's kind of confusing at first, but once you learn the rule and you understand what it's all about, it's very easy. All right, now 8. If you look at this, if there is no exponent listed, then the exponent is automatically a 1. See, look at this. N, how many n's are we multiplying together? We're multiplying 1. So any letter without an exponent is automatically n to the first power. So we don't do anything with the negative 4. And we have n to the 1 plus 3, which gives us negative 4 times n to the 4th. Remember, this exponent, when it's next to the letter like that, is only the exponent for the letter. It is not the exponent for the coefficient. All right, number 9. Let's look at this. So if I have x times y, which is what xy is, times x, 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 x. There are 5 x's there, 1 x here. So I would add up all my x's. That would be x to the 6th y, because there are 6 x's. So we're just taking everything we're multiplying together. All right, number 10. We're going to do this with 2 variables. So I have x, x, y times x, 1, 2, 3, 4, 5, 6, 7. How many x's am I multiplying together? I've got 1, 2, 3, so that's x to the 3rd. And then my y's, I have 1, 2, 3, 4, 5, 6, 7, 8. So it's y to the 8th. All right. Now, this looks kind of confusing, but we can just do it like this. 2 times negative 3 times e times e. So 2 times negative 3 is negative 6. How many e's are we multiplying together? There are 3, so your exponent is 3. Okay? We can do the same thing on 12. Negative 3 times 2 is negative 6. And then d to the 3rd times d to the 4th, we add the exponents. That equals negative 6 d to the 7th. All right. So on number 13, word problems. It's always good if you have a rectangle. It says find the area of a rectangle. So here's a key word, area. The formula is area equals length times width for a rectangle. So if this is 4b squared and this is 2b to the third, then we have 4b squared times 2b to the third. First things first, let's take our numbers and multiply those. 4 times 2. And then we have b squared times b to the third times b, and then we're going to add the exponents. 2 plus 3 equals 8b to the fifth. Again, we have area of a rectangle for 14. So if I call this 5 x squared y, and this is x cubed y cubed, so this is L, this is W, we say A equals 5 x squared y times x cubed y cubed. Okay, so we don't have a number to multiply the 5 by, so we're just going to write him down. And then we're going to take our x's, and I have x squared, and then I'm going to add this exponent over here, and then I have y, and since there isn't an exponent, I'm going to go ahead and put in 1, and I'm going to add the other one. And what that gives me is 5 x to the fifth y to the fourth. This is something you should really practice. Learn the rule. Learn it, learn it, learn it. Own it. Don't just memorize it for a quiz or a test. You need to own this so that it is yours. You will be using this and other things as you progress in your math career. Have a good day.